This is our presentation on server deployment and virtualization management for our system administration and security class. According to Stephanie Sanjara at IBM, there's some rapidly advancing cloud computing, data management, and artificial intelligence that's going on, and it's crucial components for the future of IT infrastructure. We wanted to familiarize ourselves with how we could support this infrastructure, so our group deployed and configured a Windows Server 2022 and a virtual machine in Microsoft Azure, and then we prepared it for enterprise-style administration of virtualization. We did this using a Windows 2022 ISO from Microsoft's Evaluation Center, and then we also used the Azure portal to create and deploy the properly sized virtual machine with the required network storage and security settings. Once we had deployed the server, we used remote desktop to access the virtual machine and the on-premises server and attempted to enable Hyper-V using an elevated PowerShell command. From there, we also used the server manager to complete baseline setup tasks, such as naming the computer, joining a work group, configuring the firewall, enabling remote management and remote desktop so we could remote into the servers, disabling the NIC teaming, and setting a static IP configuration with consistent DNS settings. Finally, we also installed and validated key server roles that were required, such as the file and storage services, DNS and Active Directory domain services. And throughout this entire process, we collaborated as a team using Microsoft Teams to make sure that we could configure and test every component that we went live with. And my role for this was to deploy the Windows Server 2022 Data Center Edition desktop experience that we agreed upon as a team for the operating system. We chose this operating system because it was a little bit more recent than what it was that we were learning on the 2019. So it was a little bit more relevant to something that we might run into in the real world environment. To do this, we had to set up an on-premises server through a hypervisor. Now, the reason for this was because if I installed it on my computer, the operating system would overwrite my operating system, so we had to find a solution for that. Our solution was to do this in a Type 2 hypervisor called Oracle VirtualBox. We chose that because it's really flexible and it had a great ability to run the host operating system. Hyper-V was not chosen to do this, even though it probably would have been preferred because of how it sits on top of the operating system, because it's not available on Windows 11 Home, which is the operating system I have on my computer. To ensure that the server would run sufficiently, we allocated resources that were above the minimum requirement for server stability. So for example, 2 gigabytes of RAM might have been minimally sufficient. 4 would have probably been fine, but we chose to go with 8 gigabytes of RAM just to make sure we had enough RAM to do anything that we might need to do. We also dedicated 4 processors and 50 gigabytes on the disk. When we did the initial configuration, it was through a 180-day free trial using Microsoft's ISO, downloaded from their website. We named the server right away the CYB300_SRV1. We updated the time zones and we performed critical Windows updates. Those are some of the main things that you always want to do when you install a server for the first time. You can see in the image what it looked like when we set up the specs for VirtualBox. And you also can see what the server looked like as we were setting it up. Next, I created a resource group in Azure for organization of our resources. That provided us a place where we could do role assignment for each of the team members to make sure that people had contributor roles as well as other roles that they might need to be able to do their area. This was also done at this level to benefit from inheriting roles applied at different levels throughout the resource group. We did run into some challenges where roles were not being inherited, so there were some times where we did have to set roles at, let's say, maybe the IP or the VNet level. Speaking of those, we did create some different resources for the future Azure virtual machine that would be set up, and that was further configured by other team members. We specifically had our virtual network, We had our NIC card, which is our network interface card to connect the virtual machine and the network. We had an IP address for connectivity, and we also had the network security group to provide virtual firewall functionality. These were set up, like I said, as a basis, and then were there for other team members to use. The network security group was there also to manage our inbound and outbound port rules for the virtual machine. Next, I configured Azure Arc to make sure that we were able to connect to our on-premises server in the hybrid portal environment. We used the same resource group and selected a region for the server. We did not connect to SQL Server because it wasn't really needed for what we were trying to accomplish. We opted to authenticate manually. It gave us a script. We were able to use that script and then go into the server's PowerShell and run that script to finalize the link between the server and Azure. I also configured Windows Admin Center to make sure that was integrated with Azure Arc for browser-based server management. I had to attest to software assurance. It was pretty straightforward to do that, but it wouldn't let me move forward until I did that. We also had some issues that kept popping up errors on our screen that prevented us from using some of the regions. So I had to do some troubleshooting, figure out what that problem was. I found out it was due to the student subscription limitations. It wasn't very clear, but I did some trial and error and was able to identify a region to use. Once I completed that, we had a fully functional hybrid solution that allowed all of the team members to perform server tasks from their browser. This was crucial because it demonstrates that we had a successful execution of the architecture integration and functional role-based permissions.
Thank you for this opportunity. This is just the part about adding a static IP. It's very important, especially when you are referring to a server. The adding a static IP, why is it important? Because the reliability of clients and services, the DNS stability, firewall and security rules depend on fixed addresses, port forwarding and NAT, logging and auditing, and essential for infrastructure rules. So the best way to turn on the static part is just to basically to start with DHCP, let it pull an IP. And from there, when you allow it to pull an IP, then you can change it to static from there. There's a lot of things you can also do to make sure that you have static IP availability. One of the things is you can do an IP config, or you can do an IP config space arc pipe, which will provide you with the most reliable and open IP to use. After you figure out what IP that you need to use, then you can go to your internet settings here at the top. And then from there, you want to go to your networking tab into Internet Protocol version 4, which is TCP /IPv4 in properties. And then from there, instead of using obtain to IP address automatically, which is your DHCP setting, you want to start with this, which is use the following IP address. And from there, we used our IP address, which is 192.168.86.101. Our subnet mask is going to be 255.255.255.0. And our default gateways will be 192.168.86.1. We also want to make sure that we turn on our DNS settings as well to make sure that it's static as well. You can obtain it automatically, but we want to maintain to keep that static as well, in which we're going to use our IP address, which is 192.168.86.101. Our alternate DNS server, as requested, will be the Google DNS server, which is 8.8.8.8. After that's done, you want to click OK. And then after that, the way you can check and verify that all the information is done properly is just to open up a PowerShell window. And from there, that's all you have to do is type in ipconfig /all. That will provide all the information that you need. Here, it shows us our host name, which is the server here that we're working with. And we want to make sure DHCP is enabled, not enabled. So it shows no here. So it is correct. And our preferred IP in which we're using currently, which is 192.168.86.101. Subnet mask is, of course, 255, and our default gateway, which is down at the bottom. So here, these are things where we can check and verify to make sure everything is running on static. Currently, everything is setting on static, so we are all set and ready to go.
For my role within the team was kind of setting up and it's kind of explaining how the network configuration happened at the VM level, where I'll kind of orient you to my slide where it has a screenshot of the network settings, where it kind of covers the network interface, the NIC, virtual network, its subnet, public IP address, private IP address, and the network security group, with three text boxes kind of giving you an idea of its roles and purposes. So I'm going to walk you through how the virtual machine connects to the network, how the IP addresses are handled, and essentially closing it out with how traffic is controlled and pushed through to the VM and right back out. On the first slide, again, I'll be focusing on the virtual machine and how it connects, utilizing the different IP addresses and its purpose and all the components, and the reasoning behind utilizing each component. So the first piece would be the network interface. So essentially what the network interface is, also known as the NIC, it connects the virtual network machine to the Azure network itself. And when utilizing Azure virtual machines, we do need a NIC established in order for us to communicate with the resources on the site, as well as giving it access to the internet itself. The NIC is where it's kind of housed some important networking components that are attached, such as the private IP, the public IP, the network security group. If the network doesn't have a network interface established, then the virtual machine will not be able to will not function properly. It is required, or else it'd be unreachable or unusable for management and communication within. It wouldn't allow us to do our jobs. This will kind of lead me into the virtual network itself. So the virtual network, it's going to be located on the network interface named CYB300 VM1-VNet. And then you have the subnet to the right labeled as default. I'll go ahead and get into the subnet a little bit later, but for the virtual network piece, it essentially acts as a private network hosted within Azure. It allows us to isolate and ensure we have internal communication for the resources that we're handling. Essentially with the VNet, how it functions, it kind of acts as an on-premise environment, but on an entirely cloud-based system. Now we're going to go ahead and talk about the subnet piece. So on the subnet piece, you kind of see how it's labeled as default. So if I were to click on default, or the VNet name and default, it's going to open a second page where it kind of goes into detail what the default resembles, and that's going to give us, under the IPv4, it's going to give us an address of 10.0.0.0/24. And essentially, that's going to give us, it's going to tell us where the VM is kind of housed. So the purpose of the subnet, it breaks up the network into smaller sections again, and it assigns IP addresses. Again, the subnet's going to kind of tell us where the VM is located within the private IP address, within the network. And to kind of give further information on how the subnet is broken down. So with a /24, it kind of gives us a 256 available IP addresses. But based off the screenshot I gave you, we only have available IPs of 249. So with further research that I've done, Azure kind of takes away 5 of those 256 for more their side of the house, where they can allow us to do our jobs for network addresses, default gateways, their DNS, Azure DNS, their internal services, and then their broadcast. So now we lost 5 IP addresses, and then for our system alone, it already allocates 2 additional IP addresses, which leaves us with 249 total IP addresses for the subnet piece. Now let's go ahead and get into the public IP and private IP. So first, I want to kind of cover the public IP address. The public IP address allows the virtual machine to be accessed externally, such from a home computer like myself and other team members using a remote desktop. The public IP address was assigned by Azure and routes incoming traffic to the virtual machine's private IP, which leads me into the private IP address. So the purpose of the private IP, it was assigned to this virtual machine. The address reflects as 10.0.0.4. Again, it's used for internal communications with the virtual network and is not accessible directly from the internet itself. On the screenshot itself, it shows under the application security group, we have network security group, which is named CYB 300 VM1-NSG. If you can go on the next slide, please. This covers the network security group. Along this slide as well, I'll go ahead and cover the traffic flow at the end and how it all works together and how it all ties in. But for the network security group, it acts as a virtual firewall that controls inbound and outbound traffic to the virtual machine. But with that network security group, it utilizes a set of security rules that we established, as shown in the screenshot, reflecting RDP, allow WAC 2, and then the SSH port 20 open. Those are the set of rules the security group's gonna filter the incoming traffic to ensure it does have access and allows its access into the virtual machine itself. If it doesn't meet any of the requirements, then it gets blocked and no traffic goes through. When it comes to inbound security rules, we have 4 security rules that we established. So we have the RDP, which allows remote desktop access utilizing port 3389. That allows us to manage the Windows virtual machine. And then we have the Windows, so we have allow WAC 2. Essentially, it's the same thing utilizing 2 different ports. We have TCP and UDP. And that essentially allows us to access Windows Admin Center through a browser-based management system. And then lastly, we have the security shell SSH port 22. And again, that allows us to manage the system utilizing a command line access. Usually it's used for Linux systems, but if configured correctly, you can utilize Windows systems. You can manage the system through Windows utilizing their command line system. And then lastly, we'll go ahead and cover the traffic flow. So the traffic flow essentially starts with the public IP. So the public IP address receives the incoming traffic from the internet source, and then its purpose is to send it towards the virtual machine. But before it reaches the virtual machine, it needs to run through, as I discussed before, the network security group. So again, it's going to filter the incoming traffic based off the set of inbound security rules that we established. If it meets all the requirements that it needs, it'll allow access to reach its final destination, or if not, it'll completely block it based on the port and of different protocols. Once it gets passed through, it's going to go through the network interface, which will be delivered through approved traffic to the virtual machine. Now that traffic needs to find its way back out. So this is where the VNet kind of comes into play, where it manages the internal routing and then ensures traffic finds its way back to its originating source. So again, so we can complete our task like we're doing right now or for this project. To kind of close this out, these slides demonstrate how the Azure virtual machines are connected, address secured using core networking components working together. And that concludes my portion of this briefing.
Hello, and now we will get into the file and storage role installation. This will be pretty quick and sweet. I installed the role via PowerShell through scripting. I did have an issue, as you know, Azure does not allow straight PowerShell scripting from the software. But I was able to do a little research and download a CLI extension to PowerShell, which allowed me to access Azure, which was easy enough. So gaining access to the server was simple as an AZ login command and an AZ account set subscription command. Once I was in with that, I was allowed to install the file and service role. I won't go through the entire command as it's pretty lengthy. It just creates basically a run command in the form of create. I had to identify the resource group as well as the machine name, and then I told it to install the file and service role, and had to choose the location and which script as well as including the management tools and the Windows features. Next slide. The only issue I ran into, other than some small things, was authorization failure my first couple attempts. This was due to not having access granted. Even though I had a contributor role, there were some other fine things we had to tune. As Barrett said earlier, we kind of had to trial and error some things as to get to where we needed to be. But once this was cleared up, I was able to refresh my permissions and credentials, and I was able to remotely install the role. And that is all for my part.
All right, hey guys, installing Active Directory domain services and domain name systems. So basically what we do is to install the ADS and configure DNS on a Windows server of Azure virtual machine. We need to make sure the Windows server's VM is verified. So you look to the right here, there's pretty much a screenshot of what it looks like after we set up the ADS and DNS on the server manager. Okay. After the server VM is certified, we need to assign a static private IP, connect to the VM, and add the ADS, or excuse me, ADDS role. After the ADDS has been installed, we start the ADDS configuration and promote the server to a domain controller. Continue this after the ADDS configuration, you can start the DNS delegation. You need to verify the ADDS installation with the domain credentials. So when we log in to make sure it's verified, you get this little screen that's showing right here. Once this is showing that is our local group is available, that means the ADDS is installed correctly. After confirming that the ADDS installation is correct, we can configure the DNS in Azure. Next screen, if you use the command prompt, you can come in and find our information we're looking for. We need to configure VNet DNS settings through the Azure portal. This is achieved by entering our private IP address under the DNS service area. And then the test that we have, I need to test the DNS resolution using the command prompt. We use the NS lookup commandlet, which is what we did here. If we find this, the NS lookup commandlet with our DNS, make sure it's verified, address is shown here. That means we're online. That's it.
My role was to add an Azure Windows Server 2025 data center to the subscription we already have. It's also to test if we can really add a resource. We can add a virtual machine to the subscription that we have. We begin by signing in to the Azure portal. And once logged in, the first step is to make sure we're working inside the correct resource group. For this deployment, we're using the resource group name type 300 M1. Keeping everything inside a single resource group helps us to stay organized and make it easier to manage and remove resources later. And then next, we navigate through Azure, or you can go on the search of resources and type virtual machines, and then select create the Azure virtual machine. And then the size and the region has to be set up. And like we say, the region is really important because it might make it difficult to run the virtual machine at some point if it's not set up correctly. You go on the next. And we had also to configure the virtual machine size and also authentication, set up some password and create a some username and password. And the configuration of the network has to follow what has been set up before in the other slide presented. we have to ensure that a public address is used and use the port RDP port 3389 to allow inbound rules and also enable to connect to the server after deployment. Can you go on the next slide? And the address, like it was said before, we're gonna keep it the default subnet. It's gonna be 10.0.0.0. It's gonna be 24 for all of these parts. And the other part is left as default. Can you go on the next slide? And the last step is to review if all the information are correctly put in, and then deploy the machine. And the last thing to do was to verify once it was complete and open and connect and download the RDP file, open it and log in using an admin credential that we created, and then make sure that we have full access to a Windows Server 2025 virtual machine in Azure. That was my part.
Alrighty, so with enabling the Hyper-V on an Azure virtual machine, when it comes to this portion, it is going to be the very first step of connecting using the remote desktop protocol. So you can see that when we attempted, we are using the credentials that were utilized, so that way we can access into the virtual machine from our Windows Admin Center. From there, we would go ahead and open up the PowerShell with admin control so that we can then attempt to install the Hyper-V role using a Windows Server feature installation command. This step was created to demonstrate how Hyper-V can be enabled within a cloud-hosted environment to support virtualization workloads without maintaining on-premise hardware. The issue, though, that did come about when we were utilizing the PowerShell configuration is that upon utilizing the command called install window feature name Hyper-V include management tool restart, the issue that came up is that it failed the prerequisition check. So in the error that's occurring is that our current processor did not support the required virtualization capabilities. And this mainly occurred because we are utilizing a Azure virtual machine size that is for free. So after confirming and we went to the size limitation on Azure itself, there are the dependent and supported virtual machine size that did unfortunately cost extra money. It is the version D4S. And then from there, though, we went ahead and we're attempting to utilize the Hyper-V Server 2019 download, which is a free application that is designed for an on-premise deployment, though. So we attempted to download it and selecting the correct operating system. From there, you would get the download wizard, and then the installation would start. Some of the key takeaways, though, is that not all Azure virtual machine sizes support the nested virtualization, and that the sizing and capabilities have to be verified before enabling Hyper-V in Azure. But it still does provide the flexibility where supported configurations do exist. And through this, it shows the limitation of trying to run Hyper-V when you are in a cloud environment.
So in conclusion, this project provided our team with practical experience in building a cloud host Windows Server environment from scratch, then hardening and configuring it for real-world administrative use. Deploying the virtual machine in Azure demonstrated how quickly infrastructure can be provisioned and adjusted compared to traditional on-premises setups. Using virtualization such as Hyper-V can be layered into cloud-based server for flexible workload hosting. Completing the server manager configuration steps reinforced the importance of standardizing server identity, remote administration, firewall posture, and network addressing before adding services. Installing and testing roles such as ADDS, Active Directory Domain Services, and DNS and file services demonstrate the interdependence of these services and the importance of stage validation. Overall, our team finished with a functional Windows Server 2022 environment that supports remote management, core server roles, and virtualization capabilities, along with the troubleshooting habits that prevent projects administrators from experiencing issues. As a result, are prepared with skills foundational to supporting the growing demand for IT infrastructure. In the following slides, we have our references. And the last one will contain our URL for the video. Thank you.